Welcome everybody. You're watching Mr. Fugu Data Science. We're going to look through some troll tweets today using NLP. This is going to be part one of our mini series. Today we're cleaning and prepping the data. As always, hit me up here on Instagram and Twitter if you'd like to help support the channel. Here's my Patreon, or feel free to buy me a coffee. Let's get into this.
Беги, пока еще есть время, или иначе, мы будем троллить вас в суперсложное время. Ах да, я покажу тебе, где лобстеры зимуют.
By the way, that was a joke, so please don't get mad. These data came from Kaggle. I'm leaving a card above for you to watch if you'd like to see how to interface with Kaggle and grab the data set. But if you're interested, this highlighted data set right here is the one that we're going to use today. It's going to be 9 CSV files that you need to unzip and read into Python. By the way, the code will be on my GitHub and the link in the description below. After we concatenate all of those files together into one data frame like this, we're going to notice that we have a lot of tweets. We have around 3 million tweets. Let's scroll down and look. Yeah, very close to 3 million. These tweets are really interesting because they are Russian troll tweets that came up during the 2016 presidential election in the US. That's why this data set's kind of important. You're going to notice here that we have these URLs inside of these tweets. This is kind of an issue later when we're trying to parse using NLP. We're going to get rid of that today. Also, there's an issue with these because they may still be active links and they'll send you to places you may not want to go. Maybe it'll give you a virus or
send you to a naughty place.
But I'm not gonna keep those in there. The first thing we should check doing our exploration is looking for NaN values or null values. You'll notice that we have these 5 particular columns that have at least one null value. We have quite a bit for this post type. We're gonna need to investigate these and figure out if we need to update this information or get rid of these rows. Evaluating the account type first, we see that this is the unique account types that we have, and if you focus right here, we have this none or NaN value that we need to adjust for, and this goofy question mark, which doesn't make sense for whoever set up this data set. The next thing we look at is the post type, and notice that we have a NaN value when we're looking at these retweets or quoted tweets. The next thing we want to investigate is looking at the regions, and we'll notice that we have none values and we have unknowns. So we're going to have to deal with that. Looking at the regions, I was interested in how do these data actually spread out in terms of quantity of tweets by region. In the US, there's over 2 million tweets, and then we got this pretty big number, which is 500,000 unknown locations. But we just can't throw these away. So we got to figure out how to deal with that later when we're doing our evaluations. When you're looking at the account type, this is going to be interesting because we have, again, this question mark that we need to figure out what we need to call this. I guess we could call it an unknown. And you're going to notice political agendas, if they're going to the left or to the right. And then it just flat out says their account type was Russian because these two are almost the same size. When we're looking at the language for these tweets, the top 2 languages are English and Russian. If we were to look at the value count for this real quick to get a proportion of what these data look like in terms of languages, basically 90% of our data, 92% of our data occupied by these 2 languages for our tweets. Other thing that's going to be important that'll come up in our future video is the authors. The authors are the people who are the users throwing out these tweets or retweets. And we're going to investigate some graph theory to see how this relates to the bigger people shelling out basically tweets to other people to retweet and kind of see what their little network look like for these little troll factories. Interestingly, if you pay attention to this, these top 20 people have at least 19,000 to almost 60,000 tweets between each one of these people, which is crazy because this was like 4 or 5 years ago. And we'll also see a trend over time of how many followers these people are getting. In order to start cleaning these data, we got to deal with these individually. The post type that we're interested in before, we wanted to fill those NA values, and I'm just going to fill it with a string called other tweet. And then the region, I'm just going to fill the NAs with unknown, and then I'm going to replace any question marks for the account type by unknown, and then I'm going to fill the NAs of the account type which are unknown as well, since we had two different things that were going on there. When you're doing the fill in A, notice that you don't have to do an equal sign and then call the data frame again. Only when I'm doing the replace I have to do that. We could look then to see that we do have the unknown, which is updated, and further investigate how our NA values are doing for our columns. We still have two columns that we have to deal with here, which is only 5 more rows out of almost 3 million, which is nothing. So I decided to investigate this further and look for the rows that had the NA values equal to true. Then we're going to take the index number for those rows and drop them here. So this is allowing me to get the index position for all of the rows that return NA for the content. After we replace that, I look at after that, I looked at the 4 rows. This was 1 row. This is the 4 rows that I wanted to investigate and decide, are we going to keep these or are we going to discard these rows? Well, they do have tweets, even though they look like pure garbage with symbols and nonsense in it. We understand that, well, what this external author ID seems like a useless column what I could just get rid of and just retain the rest of this data. So I decided to just move on from this and not exclude these rows, even though this particular user, when you investigate these data, has thousands of tweets. So even if I deleted these 4 rows, it wouldn't even mean anything anyway, but I decided to keep them anyway. So I exclude 3 columns that I don't need. To make my life a little easier, I could exclude this column because we update this soon, because we're going to get rid of the URL links using regular expressions. So cleaning this up with regular expressions, we got to call in our RE, and then I'm going through the column that has our actual tweets, and I'm using this pattern to look for each string if it has HTTP or HTTPS, and I want to find all of those and do a string comparison for my iterator. And if we find it to be true, just replace it with this right here. And you could say, well, why didn't you use this and just put it in here again? Well, there's a problem with that. Some of the content has hyperlinks that are at the beginning of the string, and when you do this pattern comparison, if it finds it, it just puts an empty string, so anything that follows it is gone. That's why I had to do this as my substitution so I could retain the same string. Then I just do an update for it, call my new columns to show that I created this. Further, we see that here's our original text with the hyperlink, and here's our new portion here. And I purposefully printed off these last ones so you can see all these Russian tweets, just because. Here's another hyperlink and it's discarded. So it looks like I did what I needed to do. Now there's something else that I wanted to do. I wanted to show you how to use the Google Translate API. Yet there's a problem that persists, and it started a few months ago, but it's been ongoing for a few years. This Google API translator interfacing with Python is not working. There's a new one that was built by somebody that will work. If you're using a Python script or some kind of IDE, you should be fine to call this. But understand that there's a few issues with it. You cannot use this directly with Anaconda because Anaconda is slow to do updates for things such as this. They had a 2-year-old version for it. If you're using this in regular Python, you have a limit on the number of calls you can do per day, 200,000 and 5 per second. When you parse these data, and if you only take the Russian data, it's 600,000 entries. That means it's going to take you 3 days if you could get it to work. That's why this video has taken longer than expected, because of dependency issues with this and because of trying to figure out how to get this to work. Moving on, there's a few other issues to parse these data. There's numerous strings that need to be fixed. You have extra single and double quotations that you need to look for. So I did a regular expression to allow me to look at the beginning or the end of the string for these extra quotations. And if they occur here, you're looking for all of them, just do a string strip for each one of these separately. This code is kind of slow because, again, you're going through a few million entries doing if-else statements. It's not going to be fast. You could figure out a better way to do this, I'm sure. Probably a NumPy array. After you fix those, it'll look like this for the first few entries. You don't see a bunch of that junk. But I see one right here. Well, this is interesting because you notice that there's still a mistake right here, which means that I need to do further processing on this to try and catch those. What's going on with that? So it looks like there's still an issue with this that's not getting resolved that we need to investigate further. Moving on, I'll look at that later and update you in the next video. I moved that into a new column. I updated that column with this information, and then I decided to split based on the two main languages that we have. But that'll be the end of this video since we're not using the translate portion today. But I'd like to say please like, share, and subscribe. And if you subscribe, turn on that notification bell. I hope this brought utility to someone. See you in the next video for part 2. Feel free to hit me up on my Patreon or consider buying me a coffee. See you in the next one. Bye.